This video should be following your Desmos activity that you guys did. Again, you should have started to take some notes as you were working through the Desmos activity. As you're watching this video, you're going to press stop, pause, try some examples for yourself, and double check your work. Again, you should be adding these examples into your notes. Let's start with a warm-up. We're going to be doing lots of algebra today, and I just wanted to remind you guys of that process of solving for x. Remember, you're using inverse operations. If you see addition, you're using subtraction. If you see subtraction, you're using addition. If you see multiplication, you would use division. If you see division, you would use multiplication. Please pause this video, try these 4 examples on your own. Make sure you can get those answers that you see at the bottom before moving forward. Another thing I wanted to remind you guys of before we get into our work with inverses is how to find the domain and range of particular functions. This is going to be important today as we are finding our inverse. So the first function we want to look at that has a restricted domain is your quadratic. This quadratic that you see in front of you is an equation in vertex form. From this, we can identify the coordinates of our vertex to be -3, 6. We see that this graph has shifted 3 units to the left, 6 units up, and then got reflected over the x-axis. The domain for all quadratics is all real numbers. Because this graph is upside down, that means that 6 is your largest y value and your range is -infinity to 6. The next function that is important that has a restricted domain and range is your square root function. Square root functions have a point of origin. The point of origin is where the graph initiates. Again, we're thinking about graphing your eyebrows here. They are either the left or the right eyebrow. Based on our transformations, this graph is moving 2 units to the right and 5 units down, giving us the location of that point of origin. That point of origin is super important when identifying your domain because your smallest x value is 2 and your smallest y value is -5. Identifying our domain to be from 2 to infinity and our range to be from -5 to +infinity. So as you discovered in the Desmos activity, we're starting to remind ourselves all of those key features about finding inverses from Algebra 2. Remember that to find an inverse, you need to switch the x and the y values and then solve for y. Again, all of your operations are going to change. If it's addition, you isolate the y using subtraction. Everything is opposite what it was in the original function. The result of finding the inverse is that the domain of the original function becomes the range of the inverse. The range of the original function becomes the domain of the inverse. The original function will be reflected over that line y equals x for the inverse. And all of the transformations of the original function will be the opposite for the inverse. Again, if something had an impact on the x, now it will have an impact on the y. Everything is switching. So horizontal transformations will turn into vertical translations. Everything is going to be exactly opposite. This is nice because no numbers are ever added or removed. They just get moved to a different location in the function. Again, you should be pausing the video at this point, making sure you have copied all of this down into your notes. I'd like to go through some examples of how to find the inverse and how this graph would look when we graph the inverse. As we mentioned on the previous slide, all of our inverses will be a reflection of that line y equals x, which again runs through the origin, has a slope of 1, So let's start by graphing this function and looking at the algebra. For this function, we want to start by switching the x and the y value. going to solve for x. So add 5 to both sides. We want that y by itself, so we're going to multiply by the reciprocal, which would be 3/2. Make sure you're careful and that you multiply the whole function by 3/2. So the inverse function is 3/2 x plus 15/2. Everything that was a point on my original function will be reflected and changed for the inverse. So this point is 0, -5. So in my inverse, that point would be -5, 0. Now I could grab a few more points, or I could use that slope to graph that line. That slope is 3/2, so I'm going to rise 3 and run 2. And keep repeating that pattern until I get a few more points to be able to connect the dots into a smooth, even line. Again, all of those points from the x and y were flipped. We can see that the slope is the reciprocal of the original slope. Again, the y-intercept turned into the x-intercept. Now on this function, the domain of the original function was all real numbers. And the range of this function was all real numbers. So when I find the inverse, it still should have the same domain and range. Again, remember the domain and range are flipping. Let's go through a second example. This is an example of a parabola. Again, from this parabola, we are going to start by identifying our domain and range. The domain of any parabola is all real numbers. The range of this parabola is based on the coordinates of your vertex. This graph moved 2 units to the left and 5 down, so your vertex is -2, -5. Since -5 is your smallest y value, your range is from -5 to infinity. So let's do our algebra. Again, we're going to start by switching the x and the y. Then we're going to rearrange this equation so that we can solve for y. Start by adding 5 to both sides. Take the square root of both sides. Remember, when you add a square root, you need to add the plus and the minus. And then move the 2 to the other side. You want to make sure that that 2, as you move it from the right to the left, stays out from underneath of that radical. So using the appropriate notation, the inverse of my original function is plus and minus the square root of x plus 5 minus 2. The range from the original becomes the domain of my inverse. So the domain of this function is from -5 to infinity. The domain of the original is the range of the inverse. So my range is from -infinity to +infinity. The location of that vertex at -2, -5 is now going to be the location of the vertex of my inverse, which is going to be -5, -2. Now I could grab some points from that parabola and switch their coordinates. I could also use what I know about patterns to plot that graph. I know that when I'm done, I should have a smooth, even parabola. Again, the shape from the original has to be protected to be the shape here. We can also look at our domain and range to make sure that our range is all real numbers, but that our domain starts at -5 and goes to infinity. What I notice about this is that the inverse is not a function. We will add a definition to this when we get back from midwinter break that ensures that both the original and the inverse are still functions. Our third example that I want to go through is a square root function. Square root functions have both restricted domains and range, so it's really important that that is where we start, is by identifying the domain and range. Looking at the function, I know that this graph shifted 3 units to the left, so that means my domain is from -3 to infinity. This graph moved 1 unit down, so my range is from -1 to infinity. Algebraically, to find our inverse, we're going to start by switching the x and the y. And then we need to solve for x. Start by moving the 1 from the right to the left. We want to get rid of that square root, so we're going to square both sides. Then we want to isolate the y, so we're going to subtract 3 from both sides. Using the appropriate notation, this would make my inverse function x plus 1 squared minus 3. Now, think about the shape of a parabola. We do not want that full parabola. We only want half of the parabola to get that square root graph. So we have to pay attention to what part of this square root do we want. When we look at our range of the original, that needs to be the domain of this function. So x needs to be from -1 to infinity. The domain of the original is the range of my inverse, so this needs to be from -3 to infinity. So the way we can cut this function off so that we only have half of the parabola is to put a little semicolon there and say we only want this to be true when x is greater than or equal to -1. So we're saying we want to graph this parabola with this accommodation that x can only appear on our graph when it is greater than or equal to -1. Looking at a few points, the point of origin for this square root function was -3, -1. So in my inverse, that point needs to flip, so it's going to be -1, -3. And again, we're graphing just the positive half of this parabola. We can grab a few points off our graph or use patterns in order to get that chunk. So we are going to do the math to find that location of the parabola, but then we're going to restrict it at the end so that we only get the positive chunk of the parabola. Again, you have to make sure that your range from the original follows with you to your inverse and becomes the domain of your inverse. So I want you guys to try 3 on your own. Again, notice there's a linear, a quadratic, and a square root, just to give you guys an opportunity to see 3 different function families. You should be identifying the domain and range for each, and identifying your algebraic steps to find the inverse. At this point, you should pause the YouTube video. Make sure you're writing down these 3 examples, attempting it on your own before you move forward and look at the solutions. All right, so let's see how you did. The first one was linear. So the domain of any linear function is all real numbers. And the range of any linear function is all real numbers. In order to find the inverse, we switch the x and the y. And now we're going to rearrange this and solve for y. Start by moving the 9 from the right to the left. Now we're going to isolate the y by dividing both sides by -4. as we use the appropriate notation, we'll clean that up a little bit. Remember, we're not allowed to leave a negative in our denominator. The range from the original becomes the domain of my inverse. And the domain from the original is the range of my inverse. Because those are all real numbers, you can't tell that they were switched, but they were. Looking at the quadratic, again, it's important first you start by looking at where is your vertex. The vertex for this function is at -1, -5. That will help you identify your range. The domain for all quadratics is all real numbers. For this one, the range is from -5 to infinity. Let's look at the algebra. Again, start by switching the x and the y. Now we're going to rearrange this so we can solve for the y. Start by adding 5 to both sides. Before we take the square root of both sides, we need to get rid of that 2. So then we're going to divide both sides by 2. Again, watch your order of operations. Next, we're going to get rid of that square by taking the square root of both sides. And we're going to isolate the y by subtracting 1 from both sides. Using the appropriate notation, that would tell us that the inverse of the function is plus and minus the square root of x plus 5 over 2 minus 1. The range from the original becomes the domain of my inverse. And the domain of the original is the range of the inverse. We will be adding more to this definition after we get back from midwinter break that cleans it up a little bit. Because if you're noticing, this function is, or the inverse is not a function. So we would need to make sure that when we find the inverse, it is a function. So we'll talk about that when we get back from midwinter break. The last one I asked you to do was a square root function. The square root function was set up just a tiny bit differently to see how well you guys were paying attention. When we look at trying to graph this function, again, we have to recognize first what's happening underneath of that square root. This is really negative x plus 4 underneath of that square root, which means in order to see my transformations, I have to factor out that -1. That's important because that is actually a reflection over the y-axis. Your graph is moving 4 units to the right and 2 units up. So the location of your point of origin is 4, 2. Because of that negative underneath of the radical, it's causing a reflection across the y-axis and your graph is going backwards. So as we're identifying our domain of this function, the domain of this function is actually -infinity up to 4, and your range is from 2 to infinity. So let's look at this algebra. Start by switching the x and the y. Now we're going to isolate for the y, so you're going to move the 2 from the right to the left. Then we want to get rid of that square root, so we're going to square both sides. We want to next move the 4. It's positive on the right, so it becomes negative on the left. Now we want y by itself, so we're going to divide both pieces by -1. That -1 is going to go on the outside of the square. So using the appropriate notation, Remember that the range of the original is the domain of my inverse. And the range of the original is the domain. The domain of the original is the range of my inverse. By taking this parabola and restricting the domain and range, it'll guarantee that the shape of my inverse function is the same as the shape of my original. So you have one last step of this activity, and that's to go back to Schoolology and do the post-activity assignment. Make sure you've copied all of this into your notes. You're starting to remember this from Algebra 2.